So today's lesson will be recorded. So if you are not comfortable with your voice being recorded, please just send me a chat message and I can respond anonymously to you. So today's lesson is, we are in chapter 8, and this is area moments of inertia. Essentially just moments of inertia, right? That's what we're dealing with here, moments of inertia. Now, this idea, this moments of inertia, inertia is the tendency of object to stay in current state. So at rest or in motion, right? So this is static, so everything's staying at rest. So, and we also learned, that's what inertia is, and we learned what moments was, right? That was a twisting force, or a force causing rotation. I'll just call it a twisting force. So if we have can you picture a yardstick, right? A yardstick. So we have this three-dimensional yardstick, and that's pretty thick. But anyway, there's essentially three axes through which this can rotate. It can rotate on the XX axis and the YY axis. Those are our two axes that we're dealing with. And there's also the ZZ axis. We're not dealing with that axis. We're just dealing with these two, X and Y. And it's symmetrical about both of them. Now, when you look at this, if you were mentally picturing or physically picking up even your pencil, you can use your pencil or your pen or whatever you're holding. If you rotate it around the XX axis, right, around this axis, versus rotating it around the YY axis, it's a lot more difficult to rotate these big ends through the YY axis. Now you got to picture that in 3 dimensions. Than it is to rotate it along the XX axis, right? That's a lot easier to spin it rather than to rotate it. And that's what we're measuring here. We're measuring how difficult it is to rotate the object. So the bigger the moment of inertia, the harder it is to rotate an object. That's essentially what we're talking about here. And we're looking at it in terms of area, because that's what we did in the last chapter. Now the units are going to be to the 4th power, like inches to the 4th, or centimeters to the 4th, or feet to the 4th. So that is the thing that we are going to be kind of different than most things to the 4th power. Mentally, it's kind of hard to picture that. So in terms of the strength and stuff, we would just a twisting motion, just trying to mentally picture something that's being twisted. And the more moment of inertia it has, the harder it is to twist it. So we have our two axes, right? We're going to be solving for the sum of the i's in the x and the sum of the i's in the y, because if you only have one shape, right, like this shape, it would just be ix and iy. So this is about the xx axis, and this would be about the YY axis. Now, in the back of your book, on the back cover of your book, if you open it up, you can see moment of inertia i's, the second column in the back of the book. Those would be our values. So in this case, we wouldn't have this we would only have a 2-dimensional shape here. But anyway, our rectangle, you can see in the book, it says Ix naught equals BH cubed over 12. Iy naught equals HB cubed over 12. And then Ix equals BH cubed over 3. So the way that works, let me just erase my shape here and give us something a little bit more 2-dimensional. The way that works is, if we have our shape, right, we're always going to be dealing with what we call X naught and Y naught. Those are the centers of our rotation. So when you look at it, when you're dealing with Ix, you're always going to use this X naught. And then IX would be down here at the bottom, at the base. We don't use that very often. That's not something we're going to be dealing with. So you don't have to worry so much about this. Although one of the homework problems does talk about it, but don't get yourself all worked up. That's probably the only one that is going to worry about the base. We're always looking through the centroidal axes, right? The point, the centroidal axis. This is our key to all of our problem solving. Now, when you have more complex shapes, so this is just for a simple shape, we would essentially say IX equals, so BH cubed. If I gave some distances here, let's just call this, I don't know, 6 feet, and I'll make this 11 feet. So B would be our base. This would be our base. And this is our height. So IX is actually IX naught would be 11 times 6 cubed over 12. And IY would be 6 times 11 cubed over 12. So if you have a simple shape and the centroidal axis goes through the center of the shape, like this shape it does, you can just use your straight I formula. So if the centroidal axis, so use only I formula if centroidal axis goes through shape's center. How's that sound? Now, if you have a more complex shape, let's say, I don't know, let's just do this. We got 2 shapes now. And just give it some distances. Does that look okay? So now we have 2 shapes. You can see that the YY centroidal axis goes through the center of the shape. So when we solve IY naught, IY, you're going to have IY1 plus IY2, or I2Y, whatever, however you want to say that. So we would do the HB cubed over 12. So you would do your 2 shapes because it goes through the center. You don't have to do anything special. So to solve this, you would say sum of the I's into Y is, I think it's HB cubed over 12. So HB cubed over 12. So the height of shape 1 is 6 times 4 cubed over 12 plus 1 times 10 cubed over 12. Sum of the IY is equal. I'll just put this in my calculator quick. That can't be right. Yeah, I got 32 plus 83.33. I don't think that 32 is right. Yeah, it is. So then sum of the I's and the Y would equal 115.33 feet to the 4th power. So you see, when it goes through the center, you can just do that. Now, you may be asking yourself, oh no, right? Here's the center of this shape. Here's the center of this shape. So XX is going to be in the middle of those 2 somewhere. And now we have to find our distance Y bar to find out where XX is. So to do this, what we're going to do is you have to find how far the center of the shape is from the XX centroidal axis. You have to find that distance. Over here, that distance was 0 because it was right on the YY centroidal axis. So you didn't have a distance, right? This horizontal distance was 0. But when we're doing it in terms of this, the way it's going to be written, and I'm just going to write it out here. It may look funny, but each one, Ix naught or x1 is going to be I1 or Ix1. Sorry. Ix1 is going to equal, I already wrote Ix1. Well, it's going to be Ix for 1 plus A1 Y1 squared. Sorry, I got the squared in the wrong spot. I lost my mind for a second there. A1 Y1 squared. So for that shape, right, you're going to use Ix plus A1 Y1 squared, where Y1 is actually, this value Y1 is going to be Y bar minus Y1. So your formula actually is going to be Ix1 equals Ix plus A1 Y minus Y1 squared. So anyway, it looks harder than it really is. So this distance here is actually this, remember this is Y1. This is what we did in chapter 7. So Y1 would be here, it'd be 3 feet. So whatever this distance is between these two, so if this is whatever, we'd have to find Y bar and we subtract 3, so it'd be Y bar minus 3. So that's a little bit more complicated. But these are fun. Once you figure it out, it's pretty easy to do. It's really not very difficult. But we will be, you can notice we will be finding Y bar for every problem. Pretty much. So that's what we did in chapter 7. So luckily everybody did such a good job in chapter 7 that we won't have to worry about you not being able to do that stuff from chapter 7, because that's sometimes a fear. If you can't figure out how to find Y bar, you can't really solve these problems. So let me just go ahead. I'll finish up this problem and show you how to do it. And then hopefully by the end, it'll make more sense to you. So I'm just going to erase this. And I'm going to go through how I would solve this problem. And then we'll take it a little more, do some more. So the first thing I'm going to do is find Y1 and Y2. So Y2 is from here to here, right? Y2 is going to be the 6 value plus that. So Y2 is 6.5 feet. And over here, I'm going to write down A1, which we know is 4 times 6, 24 feet squared. And we have Y1, which I already found out to be 3 feet. Then we have A2, which is 1 times 10, 10 feet squared. And Y2, which I found to be 6.5 feet. Now I need to find Y bar, and this is what we did last chapter. So remember, I'll write it up here. Y bar is A1 Y1 plus A2 Y2 over A1 plus A2. So Y bar equals 24 times 3 plus 10 times 6.5 over 24 plus 10. Y bar equals 4.03 feet. So that's our first important value, Y bar. And now over here, we have everything we need. They're both rectangles. So the I formula from the back of the book is BH cubed over 12. That's the formula for a rectangle. I'll just put a rectangle here so we can remember. So now I just say the sum of the i's in the x equal, I'm going to have I x1 plus a1 y bar minus y1 squared plus ix2 plus a2 y bar minus y2 squared. That's my formula. And I had to write it on top of each other. Normally I'd write it linearly, but I don't have a big whiteboard. So sum of the i's in the x equal, well, ix1 is bh cubed over 12. So for one, shape one, the base is 4, 6 is the height, that's cubed over 12, plus a1, which we found, we're always going to be finding that in the beginning, 24, 4.03 minus 3 squared, that's our first value, plus ix2. So ix2 would be, you can see it's important to remember which is the base and the height. 10 times 1 cubed, 10 times 1 cubed over 12 plus the area we found over here is 10. And now we have 4.03 minus 6.5 squared. So it doesn't matter, that's going to be negative because that's going to be squared, which will get rid of the negative sign anyway. And now you just add them together. So sum of the i's and the x equal, this is the hardest part of getting all this in your calculator. You got to be able to use parentheses correctly. And 59.3 out. And we solved our first problem. Anybody have anything clarified there? Anywhere I lost you? I know, kind of fast. Probably went a little fast for your first problem, but I was just trying to make our way through it. Anybody have any questions? You can see in the book on page 166 that the book uses a chart. They put everything into a chart. I mean, you can do that if that helps you, that's fine, but I don't normally use a chart for these. I just list my variables. And the columns and the Y flanges or the W flanges, they have a moment of inertia column in their charts as well, and back in table A and table B. Am I still live here? Is it on? Am I on?
Yeah, you're on.
All right, good. Nobody's saying, I don't hear any breathing or nobody's saying anything. I don't hear any dogs barking or anything. Glenn's not eating a turkey leg during statics class. Do you have any questions on any of this? Ready for some more? It's fun. I think it's fun. I'll do one more with you, and then I'll let you guys do one, and then that's about it. I mean, there's only so much. This is all the whole chapter right here. Let's do a cutout. Dun, dun, dun. The hardest part is drawing them and coming up with the pictures for me. 14 inches, 9 inches, 3. Let's make this well, 4 inches. That looks the bigger. 6 inches. That's a 6-inch diameter. So this hole looks way big, doesn't it? Now it looks super small. Perfect. All right, so there's our shape. Now we have a cutout this time. So let's draw our XX and YY centroidal axes. Right, here's YY. And then if it's cut out, that'll move it up, right? It'll move it up a little bit. That's XX. And I'm going to put in my other axes. This one has his, it's right in here somewhere. And this one has hers right in there. So we'll call this shape 1, this shape 2. We have ourselves a semicircle and a rectangular box. I always like to just go ahead and find my distances right off the bat because I know I'm going to need them. So I'm just going to go ahead and find A1. That's 9 times 14. Is that 130 or 126? Is that right? Ah. 126. And then Y1 is going to be from here to here, 4.5 inches. A2 is, what is that, 4R over 3 pi? 4R over 3 pi. So that's, the diameter is 6, so the radius is 3. Right, this is 3 inches here, although it definitely doesn't look like it in our picture, but whatever. So 4 times 3 over 3 pi, so that's 4 over pi. 1.27. That's not the area, that's y. I'm sorry. I was doing the wrong thing. A1 is pi r squared over 2. So that's going to be pi times 3 squared, so 9 pi over 2. 14.14. And then Y2 is 4R over 3 pi. So that was 4 over pi, 1.27. And then we can go ahead and find Y bar. Y bar is going to be 126 times 4.5 minus 14.14 times 1.27 divided by 126 minus 14.14. .91. So a little bit higher. So that's Y bar. So now we have what we need to solve the problem. All we got to do now is use our formulas. Did I lose anybody finding Y bar? Let's review. I know it's been a long weekend. How many chat messages? Just one. Rajni, did you make it? All right, so let's do the easy one first. We'll do IY first. So this is just going to be I1y minus I2y. So if we look at a rectangle, and remember it's HB cubed over 12. Let's write it out. And then a semicircle is Now you got to hold it upside down to make sure you got it right. So we're definitely doing it in the X. Now, if this were on its side, like, well, the formula, let me write the formula down first. 0.1098 r to the fourth. If this were on its side, class, right, then you have to use, now we're using the Y formula. So if it's on its side like this, then you have to use the 0.397927 r to the fourth. So it helps to have your book and just hold your book which way it's pointing, so you get the right one. You know what I mean? Anyway, I'm sorry. If it's on its side like that, you would use this. Yeah, sorry. All right, so let me erase that. Now we plug in our values to find IY. 9 times 14 cubed over 12 minus 0.198 times 3 to the fourth. You got to be able to use the cubed button on your calculator. So it's either going to be a Y to the X button. So you'd put 3, and then you probably hit enter, or you hit the button, sorry. So you'd hit 3, Y to the X 4. In this case, it'd be 14, Y to the X 3. Or maybe you have a caret button. So that would be 14 to the third power. Those are probably your two choices, I would guess, for the third. So now you have to put this in your calculator. And I got 2049.1 inches to the fourth. Anybody else get that? Yep, 2049.1. So that's the easy one. And then the X. So we're going off the X centroidal axis. Oh, class. I used the wrong one. I got all excited about my example and I screwed it up. I used the X instead of the Y for this. Sorry, I was looking at the X. It should have been 0.3927 r to the fourth. Got to put that back into our calculators. It's going to be pretty much the same. 2026.2. Sorry, I had that backwards. Now we can do the X. In the X direction, we're going to say the sum of the i's in the X equal I1X plus A1 y bar minus y1 squared minus I2x plus A2 y bar minus y2 squared. Sum of the i's and the x. Well, in the x direction, we have bh cubed over 12. I don't really feel like writing that down, so I'm just going to go with it. bh cubed over 12. So the base is now 14 times the height, 9 cubed over 12, plus area 126 times y bar, which is 4.91 minus 4.5 squared, minus the semicircle in the x. This is the one I should have used last time, 0.1098 r to the fourth. Plus, this is a bracket, plus 14.14, 4.91 minus 1.27 squared. And then we can put that into our calculator. I got 22754.9. Now this is to the fifth. This is 27549. Big number. So, right? What you guys got? I can try again. Seems pretty big. That time I got 675. That one seems more right. What'd you guys get? You still there?
Yeah, we're here.
Anybody get? I got 675 the second time I put it in. I don't think this is right. Am I gonna have to do it a third time? Anybody get either of those numbers? Yeah, I think my second one's right. 850.5 plus So I get 871.68 for the first two numbers, and then I subtract the other two. So 675 sounds right. $675.44. Anybody have anything they need clarified there? Oh, it's already 6:40. Time flies. All right, I'm going to stop or mute. All right, let's try one then at our seats. See how we do. There's some ideas here in the book. All right, so this one's easier because your W4 by 13, you can use your book and get all the information out of the back of the book. So give this a try at your seats. And pause the recording and you can ask questions as you go. All right, so here's our startup data. I wrote it down for you. I got the W4 by 13 stuff here out of the back of the book in chart A, or appendix A, I guess they call it. That's all given at the bottom of page 487. 487 at the bottom of the page. And then A2 and Y2. So our centroidal axis, this guy's is here, this one's up here, so we only had to worry about in the Y direction. So the first thing we're going to do is find Y bar. I got 3.30. That's Y bar. 3.30. seems weird to me for a second. $2.39. I knew that seemed a little high. I think I forgot to bracket the bottom. 2.39 inches. That sounds better. 2.39 inches. So then I can just go ahead and solve for my sum of the i's and the x. That's going to be I1x plus A1 Y1. A1 times Y minus Y1 squared plus our rectangle. So that's going to be I2x plus A2 Y bar minus Y2 squared. So sum of the i's and the x. So we got I1x right off the chart. That's 11.3, or IX1 I called it. 11.3 plus 3.83 times 2.39 minus 2.08 squared plus, well, this is BH cubed. It doesn't matter because it's 0.75. So 0.75 times 0.75 cubed over 12 plus 0.56 times 4.54 minus 2.39 squared. Sum of the i's and the x equal 14.28 inches to the fourth. And then the y's are much easier. Sum of the i's and the y. That's going to be I1y plus I2y. So this is going to be sum of the i's and the y equal 3.86. That's given, plus HB cubed over 12. $3.89.